Welcome everyone to Bog the Wombat's second episode. This time we're looking at a pocket computer from the early 80s. This is a Sharp PC1500A, which was the second version of the PC1500. Starting with the case it came in, I picked this up for £26 from eBay, so that's about €30. It's a feast of brown. It does just reek of the early 80s. What we've got is the micro cassette recorder I bought separately to provide tape backup for the system. There is a carry case, very nice leatherette carry case. I've added some additional paper rolls. I've got thermal paper rolls, but it does take plain paper. It came with some little overlays for the programmable keys so that you can set up custom keystrokes and commands. It also came with the little pens for the printer mechanism, which also provides the cassette interface. I will be providing a bit of an overview of how I got the pens working. Then here we have the cables for the cassette recorder and the unit itself. So you've got the computer and then the printer and cassette interface. This uses the little Alps plotter mechanism that you see in various widths on other printers of the age. So it was used by Commodore, it was used by Tandy for the TRS-80, it was used by Atari. The mechanism itself comes from Alps, and they did it in several widths for different printer manufacturers. So the problem with the unit is that it has got leaky batteries. I don't know if you can see that, but it has staining on the outside. Popping off the unit itself, there isn't much evidence of damage on the unit itself. All the damage is inside, I suspect. And then you have lots and lots and lots of corrosion and damage to the stickers on this metal plate. So the acid from the batteries will have got inside the printer unit as well as the computer itself. In terms of the specs of the unit, very, very light by modern standards. The 1500A was the enhancement, which had 5.5K of RAM. Yep, you heard me right, 5.5K. Not even meg, K. This has got the 16K expansion unit on it. So this gives 16K of battery-backed RAM, which you can effectively write, protect, and use like a ROM. It has a single line LCD which you can program either using text or as a bitmap. So you can do some very simple graphics, but the intention is that anything like graphics is done on the printer. I first encountered these in 1989 when I was working at Plessey, and they were used to provide simple programmable calculator functions to offload work from running it on the VAX 11780 that we all shared. So without any further ado, let's get on with the repair. First part of the refurbishment is to replace the battery in the static memory module. This is a small lithium coin cell that's mounted on the PCB. So obviously you've got to take the memory module out and then open it up to get access to the board. As you'll see, I had a little bit of trouble getting this apart, mainly because I was trying to avoid damaging any of the locking tabs that hold it together. In the end, I did actually damage them, so I ended up taping the thing back together. But after a certain amount of toing and froing, I successfully got into the unit. So now I've got the board open and the battery exposed, I can replace the coin cell. I'm marking the polarity of the battery because after doing a check, I found that the replacement I'd got, while it was the same size of cell, it was actually the other way up. So one has positive at the top and one has negative at the top. So obviously if I'd have put the cell in the same way as the one I'd taken out, I would have reverse biased the RAM and quite possibly damaged it. So now all I have to do is solder in the new cell. It turned out to be not so straightforward because the new cell, the tabs were slightly bigger than the old one, so I did have to trim them down a little bit just to get the battery to fit without fouling the box. It was during this process that I caught the box with the soldering iron and melted one of the tabs, which resulted in me having to tape the box closed. But anyway, here's a montage of soldering the battery up, putting the thing back together. The only thing of note, if you're doing this for yourself, if you look at the video, I have the return spring for the shroud for the connector on the outside of the shroud. That turns out is wrong. The spring actually goes on the inside of the shroud. There are two strips on the back of the PCB to stop it shorting out. So if you're doing this yourself, just take note of that. I did later disassemble the module and put the spring in correctly, and it improved the operation of the shroud no end. The next stage in the repair is to sort out the damage caused by the leaking batteries on the computer itself. Surprisingly, when I opened it up, the contacts were in pretty good order. What seems to have happened is that most of the gunk out of the batteries has gone downwards and into the printer. So I was expecting that most of the damage would actually be in the printer itself. There was a little bit of corrosion on the terminals, but nowhere near as much as I was expecting based on the amount of carnage that was seen on the top of the printer. So once I was inside the unit, it became apparent that the damage was worse than I was expecting. It didn't look too bad at first, but if you see, the wire to the negative terminal is just floating in the air. The connection to the positive wasn't quite as bad, but it still wasn't very good at all. I think what's happened is that the battery acid has soaked down the wires and onto the PCB. I was stripping sections of the wire off, and as I stripped it off, the wire itself was looking fairly contaminated all the way down. So I decided that we needed to replace those wires. There's also, if you look at the spotty bit above the 4 devices at the top of the unit, that is a foam support strip. That had broken down and was absolutely disgusting, so that had to be replaced. Taking the bottom PCB out of the unit revealed the amount of damage that had been done by the acid, so it was a case of cleaning everything up, starting with vinegar and then moving on to alcohol, just to try and get things clean. I wasn't happy with the result, and I did notice that a number of the tracks were quite damaged, so I ended up stripping out the power supply components, including the hybrid device, the big maroon rectangle, so I could get at the circuit board and perform all the repairs that needed to be done. This was done by cleaning up and then rebuilding the tracks using solder, just to make sure that anywhere where the copper was eroded a bit thin was sorted out and wasn't going to give problems in the future. Anyone of a certain generation like me will remember Haynes car manuals. Especially when you got your first car and you were desperately trying to keep it on the road. It always had long, complicated descriptions of how to disassemble things and repair things. And then they always seemed to say the same thing. Assembly is the reverse of disassembly. And it never was. So it proved to be in this case. Once I'd got everything cleaned up and rebuilt the tracks, I started reassembling things and ended up making one fundamental error, which, if you don't spot it during this section of the montage, I'll share it at the end. So let's play a quick game of Spot the Difference. Before. After. Before. After. Anybody notice that I'd put the hybrid circuit back in the wrong way round? I didn't. It took me a week of fault finding before I realised. The problem is I'd straightened and rebent legs several times, so I decided that I'd mount the hybrid on the other side of the board since there was room. I packed the back edge of it with silicone just to make sure that there was some extra support and vibration damping to keep the stress off the legs so they'll not break in the future. The computer still wasn't working once I'd got the power supply repaired, and I couldn't see anything on the boards, so I split the flexible cables off the PCB. This showed damage which I wasn't able to capture on video because of various problems. But what had happened was there were breaks on the first 8 or 9 pins of the flexible cable. The shot here is the repairs that I made, but you can see there's still some green goo kicking around which needs cleaning off. Where the tracks had failed is the interface between the gold-plated contact section and the copper of the PCB. If you look at the PCB layout, then you can see that these first 9 pins have got 2 grounds, and all the rest are various power supply rails. So there's VGG, which is the maintained battery backup voltage. VCC is the main operating voltage. Then the other voltages are various bias voltages for the LCD. And in the middle of all this is ground. And it was only these pins that were affected. So my thinking is that what's happened is that when this thing was put into storage with the batteries left in, they had life in them. There's been a little bit of condensation or water got in, and that's allowed current to flow through the liquid between the VCCs and the ground, and this has caused the copper to migrate from the positive voltage pins towards the ground and broken the connections. And unfortunately, with the design of the PC1500 and the PC1500A, the top board with the display has all the ROM and RAM on it as well. So if you lose power up to that board, then nothing at all will happen because the processor won't boot. So anyway, I did what I could to solder it up and put everything back together, and fortunately at this point the unit came up and gave me the default message that said it was restarting from blank and its memory was clear. At this point I was able to move on to looking at the printer and the cassette. Here you can see the damage on the printer caused by the leaking batteries in the computer, plus a broken clip there which I can't do anything about. Fortunately, the plotter unit appears to have been untouched, so I could see no evidence of damage there, because if I had, it would have been game over. Inside you can see corrosion on the main PCB, but it seems to be limited to the bottom edge where the worst acid damage on the top surface is. The worst bit of damage was that resistor just there, which is completely destroyed. It's a resistor used to set the failure level for the battery warning. So if the rechargeable batteries in the printer get too low, then the computer will display an error message on the screen basically telling you to charge the batteries. It does only give you an error number, but you then, at least you know. So taking out the damaged potentiometer, I didn't actually have one that fitted. So what I ended up doing was constructing a alternative unit using flying leads, so I could tuck the replacement potentiometer up in a gap further up in the case. It's not actually that important, if you don't mind the thing just going dead if the batteries go low. I did set it approximately to the same position as the previous potentiometer. Obviously I couldn't measure the value of that because it was so badly corroded and fell apart as soon as I touched it. So what I had to do was just take a guess. I haven't been able to verify the operation of the potentiometer and the detection of low battery voltage, but that's something I'll try when I get round to using the unit a little more intensively. So moving on, it's now come time to replace the batteries in the printer unit. It originally shipped with a set of 5 750 mAh NICADs. Those are being replaced by 5 AA sized nickel metal hydride batteries with about a 2 amp hour capacity. I'm soldering the battery pack together and I can hear people shouting and screaming and saying that's not the right thing to do and I should be spot welding, but unfortunately I don't own a spot welder, so I can't spot weld them. So it's down to soldering them together using short bits of wire and making sure that I keep the heat on the batteries down to a minimum to avoid damaging them. I'm using plenty of flux to clean the terminals to make sure the joints go as easily as possible, and I have scuffed up and cleaned the terminals before I started. With a decent powerful soldering iron, the solder melted pretty quickly and there wasn't that much heat transferred to the batteries. As you can see, it's all happening very quickly indeed, so I'm pretty confident that there's been no damage caused. The original battery pack had heat shrink on it to hold it together. I tried making 3D printed TPU end caps to hold the battery together, but there just physically wasn't enough room in the case. So I was forced to compromise and use insulating tape to hold the pack together because I didn't have the appropriate size of heat shrink. I don't normally like to do that because insulating tape, as it ages, tends to creep and go goopy and horrible. So it will be a bit horrible for whoever has to change the batteries in the future. That may be me in another 40 years if I live that long, or it could be someone who takes the unit on, but that's a nice little surprise waiting for them. Once the new battery pack was together, then it was just a matter of putting it all back together into the case, connecting everything up, and then time to test it all. Apologies for the lack of video of my attempts to repair the pens that come with the plotter. I did try recording video, but everything's so small and fiddly with the setup I've got, you didn't really get anything useful apart from lots and lots of views of my hands. This is a picture of a pen taken apart. It's not the original nib unit because this is one of the ones I was working on, but if you take them apart, there's a nib section which is a rollable tip. At the back of it, it has an absorbent stick which pokes into the ink reservoir, which is basically a cotton wad which is saturated in ink. If you can rescue these from the original pens as you take them apart, then that's great, but you do have to be careful when you're cleaning the ink out of them that you don't actually cause them to fall apart. if you do, you can use a replacement from a fibre tip or a roller ball. Make sure you clean the ink out and let it dry thoroughly, and then you can cut it to length, and then you've got to tease out some of the material just to get the diameter down to fit into the barrel. You don't want it too tight in the barrel because you want as much space as you can for ink, and if you get it too tight also, the ink doesn't seem to flow very well. If the nibs are okay, that is, they haven't been left dry too long, then just a clean out. I find soaking them for 24 to 48 hours in water and then a clean up in alcohol. If they don't work after that, or they're very scratchy, what you can do to replace them is if you get a Pilot microtip roller ball or a standard Pilot roller ball. If you pop the tip out, then it's about the same length as the original. It's a little bit narrower, but if you use a little bit of heat shrink around the barrel, like you can see there, the red piece, then it'll fit nice and snug into the collar. Then all you've got to do to reassemble the pen is to put the wadding in and saturate it with ink, and then with the tip in the collar you put that on, and then you want to tweak it to get, I think it's 23.5 millimeters of overall length. You do have to watch the length carefully, because if you get it adjusted wrong, either the pen doesn't retract properly or it jams up and bends the pen cartridge, both of which I've done. The other thing to watch with the casing is where the conical section is. There's a little ball at the back. This, I think, is to stop the wadding collapsing in as you push in the tip. Make sure you don't lose that. Mostly they seem to be stuck in fairly well, but they can drop out, and if you lose them, it can give a little bit of issue. I've successfully managed to repair 3 of the 5 pens that came with my unit. One of them has a repaired tip. 2 of them have the original tip. The one that's working partially, I replaced the tip, but I managed to disturb the wick that pushes into the wadding that forms the ink reservoir, and now it'll occasionally work, but it fails more often than it doesn't. So the whole thing was not a total success, but I've got some functioning pens, which is more than I had before. One thing to watch as you do this process is be careful, particularly if you've got pens where the nib section is all metal, that when you remove the collar that goes into the pen body, make sure that if you do damage or distort the barrel in any way, that you correct that damage before you actually try using the pen. If you've got any tags like you can see on the one here, then you need to sort that out, because otherwise you're going to have problems with the pen fouling and catching up in operation. But if you've got dead pens for one of these things, or one of the other printers that uses the same mechanism, you're going to lose nothing by trying to remanufacture them. Worst thing you'll get is a non-functional pen, which you had before anyway, so nothing lost at all. So all that's left to do now is to run the tests just to see if it still works. The program I've got loaded up is the test program given in the service manual for the printer. What it does is it prints out a set of lines, and the bottom end of the lines have to match up to within, I think it's 3 millimeters for the mechanism to pass. So here I am listing out the program. This has got the black pen which I had problems with, so as you can see it's a bit intermittent, it's not working as well as it could, but it's perfectly legible, it's usable if not perfect. So we're now getting ready to run the actual alignment test itself. First stage is to switch to one of the other pens. This green pen has been serviced and is working well. And then we run the code, which is going to draw a whole set of vertical lines on the screen and will then draw some horizontals at the bottom. The check is to see how well the bottom of the vertical lines line up with the horizontal. If you're getting any mismatch, it means that the paper is slipping and you're not getting the appropriate resolution. In this case though, it works fine, so I think we can call the repair a success. So this one's going to go on one side to be pulled out when I need to do any simple graphic functions. If you've enjoyed the video, please don't forget to like and subscribe and hit the notification bell to get warnings of new videos that I produce. Coming soon in the near future will be the restoration of an HP 9000 workstation and also an HP 9131D oscilloscope and logic analyzer. Look forward to meeting you then.